Hello everybody, myself Kulnan Mukherjee. I am the Assistant Professor of Automobile Engineering Department of Dr. Sudhir Chandra Sood Degree Engineering College. Today I am going to discuss about the lift force and this will be our lecture number 9. Our subject name is Automotive Chassis 1 and subject code is AC1. Now coming to the course outcome. After having this lecture, students will be able to understand the lift force. Students will be able to differentiate between the lift force and the down force. Students will be able to understand the processes of controlling the lift force of the vehicle. Now coming to the lift force. A fluid flowing around the surface of an object exerts a force on it. A fluid flowing around the surface of an object exerts a force on it. Lift is the component of this force that is perpendicular to the oncoming flow direction. It contrasts with the drag force, which is the component of the force parallel to the flow direction. Lift conventionally acts in upward direction in order to counter the force of gravity. Okay, so a fluid flowing around the surface of an object exerts a force on it. Lift is the component of the force that is perpendicular to the oncoming flow direction. It contrasts with the drag force, which is a component of the force parallel to the flow direction. So lift force is acting into the perpendicular direction of the oncoming flow direction, and whereas the drag force is the force which is acting parallelly of the oncoming flow direction. Okay, so the lift force is acting into the upward direction or into the downward direction. That will be depends onto the vehicle body surface. Okay, and also depends onto the also depends onto the velocity of the air which is passing through the vehicle surface. Okay, and so here the lift force is the component of the force which is acting perpendicular to the oncoming flow direction, whereas the drag force is the component of the force which is acting into the parallel direction of the oncoming flow direction. Okay, and a fluid flowing around the surface of an object. A fluid flowing around the surface of an object exerts a force on it. Okay, a fluid flowing around the surface of an object exerts a force on it, and if this force is acting into the perpendicular direction of this oncoming flow direction, then it is known as the lift force, and if this force is acting into the parallel direction of this oncoming flow direction, then it is known as the drag force. Okay, so this is the basic difference between the lift force and drag force, is that when the fluid is flowing around the surface of an object, okay, it exerts the force on it. So a fluid flowing around the surface of an object, a fluid flowing around the surface of an object exerts a force on it. Within this force has the two components. One component will be acting into the perpendicular direction, and the another component will be acting into the parallel direction of the oncoming flow. Okay, so a fluid is flowing around the surface of an object exerts a force on it. Lift is the component of this force that is perpendicular to the oncoming flow direction, and the drag force is the force which is acting into the parallel direction of the oncoming airflow. Okay, now it contrasts with the drag force in this way, that is the lift is acting into the perpendicular direction of the oncoming flow direction when the fluid is flowing around the surface of an object, whereas the drag force is acting into the parallel direction of the oncoming flow direction. Okay, now coming to the down force. Down force is a downwards lift force created by the aerodynamic characteristics of a vehicle The purpose of downforce is to allow a car to travel faster through a corner by increasing the vertical force on the tires, thus creating the more grip. Okay. So downforce is a downward lift force created by the aerodynamic characteristics of a vehicle. The purpose of downforce is to allow a car to travel faster through a corner by increasing the vertical force on the tires, thus creating a more grip. The air moving under the car moves faster and than that above it, creating a downforce or negative lift on the car. Airfoils or wings are also used in the front or rear end of the car in an effort to generate more downforce. Okay, downforce is necessary in maintaining the high speeds through the corners and forces of the car to track. Okay, so here the downforce is the downward lift force. Downforce is the downward lift force. It means it is also you can also define this force as a lift force. You can also define this force as a lift force, but here this lift force is acting into the direction of the uh, acting into the direction into the weight of the vehicle, or direction into the gravitational force. Okay, direction into the gravitational force. That force will be known as the down force. Okay, so here this down force is same thing as the lift force, but here the difference between this down force and lift force is that the lift force is the lift force is acting perpendicularly into the upward direction, where this downward force or down force is acting into the perpendicular direction but into the downward direction. Okay, so the purpose of this down force is to allow a car to travel faster through a corner by increasing the vertical force on the tire, thus creating more grip. Okay, so the downforce is allow the car to travel faster through a corner by increasing the vertical force on the tire, thus creating a more grip. So when the downforce is increased, it means the downforce which is acting into the downward direction of the vehicle, so it will this downforce will be acting onto the vehicle wheels will be more. Okay, so this downforce will be acting much more into the vehicle wheel. Okay, so that's why if the downforce is maximum, then then this tire will grip more, with the ground. Okay, tire will grip more with the ground, so that if the downforce is maximum, then no wheels of the vehicle will be lifted up. Okay, so if the downforce is the maximum, then the no wheel of the vehicle will be no wheels of the vehicle will be lifted into the upward direction. Okay, so downforce is a downward lift force created by the aerodynamic characteristics of a vehicle. The purpose of downforce is to allow a car to travel faster through a corner by increasing the vertical force on the tires, thus creating more grip. The air moving under the car moves faster than above it, creating a downforce or negative lift on the car. So as you know that the air is moving through the moving at a faster rate when the air is moving under the car at a very faster rate. Okay, so the air is moving under the car at a very faster rate than the above of it. Okay, so thus creating the downforce. So if the pressure is increased, sorry, if the velocity is increased, is increased, it means the pressure will be much more lower there. Okay, so the vehicle the ve- so the air under the vehicle will be moving at a very faster rate, so that it decrease the pressure. So when it decrease the pressure, it means it increase the downforce or negative lift, so that the no wheels of the vehicle will be lifted onto the air. Okay, Airfoils or wings are also used in front and rear end of the vehicle sometimes to to generate the more downforce. Okay, to generate the more downforce. Okay, downforce is necessary in maintaining the high speeds through the corners and forces the car to track with the road. Okay. Now coming to the aerodynamic principle on lift force. Aerodynamic principle on lift force. Okay. In the frontal pressure section, the air pressure was high as the air rammed into the front grille of the car. The air slows down as it approaches the front of the car, and as a result, more molecules are packed into a smaller space. Once the air stagnates, once the air stagnates at that point in the front of the car, it seeks to move into the lower pressure area. It seeks to move into the lower pressure area such as sides, top and bottom of the car. Okay. So when the vehicle is moving, and this fluid will generate, and the fluid such as air, so fluid will be generate, or fluid will exert a force onto the vehicle body. Okay, force onto the vehicle body. So here we can also say that the air which generates a force or which exerts a force into the vehicle body. Okay, vehicle body, and this force will be exerted on the front area of the vehicle, at the front area of the vehicle, and this force will be a maximum, this amount of force will be exerted at the front of the vehicle, or frontal section of the vehicle, frontal section of the vehicle. So when these airs are rammed into this front grille, then there will be the volume will be decreased, and the density of the air molecules will be increased. Okay, and also we know that the also we know that the pressure will also increase there. Okay, pressure is also increased there. Okay, because lot of air molecules will be getting collided with each other, and as a result the volume of this rammed volume of this cross sectional or frontal area, cross sectional of the frontal area will be reduced. So that the pressure of the air molecules will be increased here, pressure of the air molecules will be increased here. And once the air stagnates at the point in the front of the car, it seeks to move into the low pressure area, because all we know that the that the fluid is always want to move from the high pressure region to the low pressure region. Okay, so fluid is always want to move from the high pressure region to low pressure region. Fluid is always tends to move from the high pressure region to the low pressure region. So once the air stagnates at the point, once the air stagnant at the point in the front of the car, these high pressure air molecules will be moved towards the low pressure region, such as at the top, bottom and sides of the car or vehicle. Okay, now coming to the second point, that is according to the Bernoulli's principle, for a given volume of air, higher the velocity the air molecules are traveling, the lower the pressure becomes. Likewise, for a given volume of air, lower the velocity of the air molecules, the higher the pressure becomes. Okay, lower the velocity of the air molecules, higher the pressure. So as you can see at the frontal area, where more and more amount of air molecules will be stagnant there, more and more of the air molecules will be moving towards the frontal area of the vehicle, and more air molecules will be getting collided with each other. As a result, of this collision, the velocity of these air molecules will be decreased there. Okay, the velocity of these air molecules will be decreased there. So from this Bernoulli's principle, we can conclude that the if the velocity is decreased there, then sorry if the velocity sorry is the velocity is decreased there, then the pressure will be increased. Okay, so due to this reason, the high pressure region will be generated at the frontal area of the vehicle or frontal area of the car. Okay, so according to the Bernoulli's principle, for a given volume of the air, the higher the velocity of the air molecules are traveling, the lower the pressure becomes. So at the frontal area of the vehicle body or frontal area of the car body, where the lots of air molecules will be um, stuck, because lots of air molecules will be collided with this frontal area. As a result, the velocity of the air molecules will be decreased, because this place will be stagnant with these air molecules. This space is filled with the air molecules, so velocity of this air molecule will be decreased. So when the velocity is decreased, the pressure will be increased, because from this Bernoulli's principle we can conclude that for a given volume, if the velocity of the air molecules is decreased, then the pressure will be higher there. And if the velocity of the air molecule is uh, increased, then the pressure will be lower there. Okay, so likewise, for a given volume of air, the lower the velocity of the air molecules, the higher the pressure becomes. As the air flows over the hood of the car, it loses the pressure, but when it reaches the windscreen, it again comes up against a barrier and briefly reaches a higher pressure. The lower pressure area above the hood of the car creates a small lifting force that acts upon the area of the hood, sort of like trying to suck the hood of the car. The higher the pressure, the higher the pressure area in front of the windscreen creates a downforce. Okay, so as the air flows over the hood of the car or over the roof of the car, it loses the pressure. Okay, it loses the pressure. Why it is loses the pressure? Because at the hood of the car or at the roof section of the car, there is a no barrier. There is a no barrier. There will be the air molecules will be accelerated. The air molecules will be accelerated there, because there will be no barrier. So that's why we can say that from the Bernoulli's principle we can conclude that if the velocity of the air molecules is increased, the pressure is decreased. Then the pressure is decreased. So at the hood of the vehicle or at the hood section of the car or at the roof section of the car, there is a no barrier. There is a no barrier. There is a no obstructions so there is no obstructions. So that's why the air molecules will be accelerated there. Air molecules will be flowing with a high velocity there. So due to this high velocity, the pressure will be decreased. So this low pressure area above the hood of the car creates a small lifting force that acts upon the area of the hood, sort of like trying to suck the hood of the car. Okay, now this high pressure area in front of the windscreen creates a downforce, because at the front of the windscreen there is again, you know, that there will be a wake formation will be generated, and there will be a barrier. There will be obstructions. So when this air is collided with this front windscreens, so there will be a wake formation will be generated. So pressure will be decreased there. Okay, sorry, the pressure will be increased there, because the velocity of the air molecules will be reduced there due to this collision with due to the collision with the front windscreen. So when these air molecules are collided with the front windscreen of the vehicle, the pressure will be increased there and the velocity of the air molecules will be decreased there. So as the pressure of the air molecules is increased, this high pressure this high pressure this high pressure of the air molecules will be act as a down force onto the vehicle body. Okay, down force will be act as a down force onto the windscreen, down force onto the front of the windscreen of the vehicle body. Okay, now coming to the rear windscreen. Now coming to the rear windscreen of the vehicle. Again there will be a there will be a barrier generated. There will be a barrier generated. Okay, and also and also mm, and also as you know, that there is a vacuum will be generated at the trunk portion and at the rear window portion, or you can also say that the rear windscreen and at the trunk portion there will be a vacuum will be generated. There will be a vacuum generated, and to fill this vacuum the air molecules from the front of the vehicles will be sucked. So the drag force will be occurs there. Okay, and due to this vacuum the high pressure will be generated there. Okay, high pressure will be generated there. Okay, so due to this vacuum or high pressure will be generated, or due to the barrier and due to the obstruction, the air molecules of the velocity of the air molecules will be distracted or reduced. Okay, so that's why the high pressure will be generated. So when the high pressure is generated, when the higher pressure is generated, it will act as a down force, as well as due to the vacuum generated. um, Due to the vacuum generation, there will be low pressure will also generated due to this vacuum, and due to this vacuum the low pressure generated, so there will be also a lift force will also act there, because there is a vacuum will be generated at the rear end of the vehicle, or at the rear trunk section or rear windscreen section, but the vacuum will be generated. And that's why due to this vacuum the due to this vacuum the low pressure will be generated there. Okay, so when the low pressure will be generated, that lifting force is also generated there. Okay, now coming to the where the most road cars are getting into trouble is that the fact that there is a large surface area on the top of the car's roof. As the high pressure air in the front of the windscreen travels over the windscreen, it accelerates, causing the pressure to drop. This low pressure literally lifts on the car's roof as the air passes over it. Once the air makes its way to the rear window, the notch created by the window dropping down trunk creates a vacuum that the air is not to be filled properly. This condition is to be said that the flow detachment, and resulting the low pressure creates lift that then acts upon the surface area of the trunk. Prior to the use of aerodynamic devices to reduce these effects, racing car drivers would feel the car becoming light in the rear when the traveling at the high speed, because when these air molecules coming into the window section, rear window section, there will be a notch created, okay, by the window dropping down, and also there will be a vacuum, there will be a barrier, and there will be a obstruction, and some amount of downforce will also be acted there. Okay, but we also know that there is a vacuum, which I have already explained to you, that we all know at the trunk section or at the rear window section or at the rear windscreen section or the rear end of the vehicle or the trunk section, there is a vacuum generated. Okay, and due to this vacuum there is a high pressure will be act, so that's why there will be a lifting tendency will be much more than the downforce tendency. Okay, so there will be the lifting force will be much more there than the downforce due to this vacuum, due to this low pressure. Okay. So prior to use the aerodynamic device reduce this effect. So to reduce these effects, the aerodynamic devices, some aerodynamic devices are incorporated with the vehicle trunk section, okay, or vehicle body, uh, such as the spoilers can also be added. Okay, so these aerodynamic devices are used to increase the negative lift, that is the downforce. Okay, increase the negative lift, that is the downforce. Okay, because for the racing car, drivers would feel the car becoming light in the rear when traveling at the high speed. Okay, because the racing car drivers would feel the car becoming light in the rear when traveling at the high speed. Okay, these empty areas are the result of air molecules not being able to fill the hole as quickly as the car can make it. Okay, these empty areas are the result of air molecules not being able to fill the hole as quickly as the car can make it. The air molecules attempt to fill into this area. Okay, the air molecules attempt to fill into this area, but the car is always one step ahead. But the car is always one step ahead, and as a result, a continuous vacuum sucks in opposite direction of the car, which I have already told you that due to this reason the drag force is increased. Okay, so here you can see this is the total profile of the lift force and the drag force onto the vehicle. Okay, so here you can see that first, when the vehicle is moving into the road at a very high speed or maybe at a low speed. Okay, so when the vehicle is moving into the road, the air the vehicle will be surrounded by the fluid such as air. Okay, the vehicle will be surrounded by the air. So when the vehicle is moving into the road, the air molecules will be going towards the frontal area of the car or vehicle. The air molecules will be going towards the frontal area of the car or the vehicle. Okay, the air molecules will be going towards the frontal area of the car or the vehicle. So as a result, that the maximum amount of air molecules are here getting collided with this frontal area of the vehicle. Okay, and as a result, as you know that the vehicle air molecules velocity will be reduced here, and also we know from the Bernoulli's principle that when the velocity of the air molecules is decreased, when the when the air molecule velocity of the air molecules is decreased, there will be a high pressure region will be generated. Okay, and due to this high pressure region, it will generate a huge amount of drag or air resistance generated at the frontal area of the vehicle against the movement of the vehicle or against the motion of the vehicle. Okay, and this force will be known as the drag force. Okay, so now this when this area is filled once this area is filled with the air molecules properly, then these air molecules will now try to move into the lower region. Okay, now, then these air molecules will try to move into the lower region. Okay, so here you can see that from the high pressure region, the air molecules from the high pressure region will be moving towards the lower pressure region of the vehicle, such as in the top of the vehicle, at the bottom of the vehicle, at the sides of the vehicle. Okay, and thus also causing the drag force onto the vehicle. Okay, now as you can see, this is the bonnet section where there is a no obstructions will be generated. So here the molecules of the air will be moving at a very high velocity or at a faster rate. So that's why there will be a lift force will be generated, because we know from the Bernoulli's principle that when the velocity of the air molecule is increased, the pressure will be decreased. So that's why at the bonnet section there will be a lift force will be generated. Okay, sort of trying to suck this bonnet. Okay, at the front bonnet section. Okay, at the front bonnet section or at the engine section. Okay, now coming to this front windscreen section. So here you can see that these air particles or air molecules will be collided with this front windscreen, and after colliding this velocity of these air molecules will be decreased. Okay, and when this velocity is decreased, it means the pressure will be increased there, and this high pressure of these air molecules act as a downforce onto the front windscreen of the car body or vehicle. Okay, now this air is getting into the roof section. Air molecules coming to the roof section, and as you can see here at the roof section, there is no obstacles are provided, there is no barrier is provided at the roof section or at the hood section of the vehicle body. So here the air molecules will be accelerated up. So that's why here the pressure will be maximum. Sorry, the pressure will be decreased because the velocity is increased here. At the hood section, at the roof section of the vehicle body, the uh, the the velocity is increased, and the pressure is decreased. Okay, pressure is decreased. So when the pressure is decreased, there is a lift force will be acting. There is a lift force will be acting, sort of trying to suck this hood, trying to suck this hood up into the vehicle. Okay, trying to suck this hood or roof from the vehicle. Okay, now coming to this rear window section or rear windscreen section, where again we know that there is a some barrier, and due to this barrier there is a velocity of the air molecule is decreased, and as a result of this the pressure will be increased there, and the downforce will be generated. But again we all know that there at the trunk portion at the rear windscreen section, where is a vacuum will be generated. Due to vacuum will be generated, and this vacuum cannot be filled easily, because when the air molecules is trying to fill this vacuum, the vehicle is moving again in forward direction, again moving into the forward direction. So when these air molecules are wants to fill this vacuum, then this vehicle will be moving into the front direction, so as a result the hole is still remain, so vacuum is still remain. And we can also say due to this vacuum the high pressure, so the low pressure will be generated. Okay, so when this low pressure is generated, it means there will be a maximum amount of lift force generated. Okay, and to fill this vacuum, the maximum amount of air which will be sucked from the front of the vehicle to fill this vacuum, so it will also causes the drag. Okay, so in this way the drag and lift force is acting over the vehicle body. Okay, so the underside of the car is also responsible for creating the lift or a down force. Okay, so the underside of the car is also responsible for creating the lift or down force. If a car's front end is lower than the rear end, okay, if the car's front end is lower than the rear end, then the front end restricts the airflow under the car, and winding the gap between the underside and the road creates a low pressure area. If there is neutral or higher air pressure above the car, then we get the downforce due to the difference in the pressure above and below the car. Okay, so the underside of the car is also responsible for creating the lift or downforce. If the car's front end is lower than the rear end, then front end restricts the airflow under the car and and widening the gap between the underside and road. Okay, creates a low pressure area. Okay, so when this front end restricts when this front end of the vehicle is lower than the rear end, then the front end restricts the airflow under the car and widening the gap between the underside and road creates and widening the gap between the underside and the road creates, okay, creates a low pressure area, creates a low pressure area because when the front end is lower than the rear end, it means the front end is restricts the airflow, and when the air enters into the underside of the vehicle or under the vehicle, then this air molecules will finding the widening gap between the underside and the road, and as a result the air molecules are accelerated, or the speed or the velocity of these air molecules will be increased there. So when the velocity of this air molecule is increased, they will create there will be a low pressure area will be created. Okay, the low pressure area will be created, low pressure area will be created. So if there is a neutral or higher air pressure above the car, then we get downforce due to the difference in the pressure above and below the car. Okay, so 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 then we get downforce due to the difference in the pressure above and below the car. Okay, so if there is neutral or higher air pressure above the car, then we get downforce due to the difference in the pressure above and below the car. So as you can see in the next slide, the airflow over a car is filled with the high and low pressure areas, the sum of which indicates the car body either naturally creates a lift or downforce. Okay, so here you can see when the air is moving through this underside of the vehicle. Okay, moving through this underside of the vehicle, as you can see that the front end of the vehicle is much more lower than the rear end, then the front end of the vehicle restricts the airflow. As a result, that when the air entering into this gap, suddenly these air molecules found the more widening gap between this road and the underside of the vehicle, and as a result that the air molecules will be accelerated up. Air molecules will be accelerated up. Okay, these air molecules will be accelerated up. So when these air molecules are accelerated up, or when the velocity of these air molecules is increased, it means the pressure will be decreased from the Bernoulli's principle. We can conclude that from the Bernoulli's principle. So when the velocity is increased, the pressure is decreased. Okay, so when the pressure is decreased, then it will act as a downforce of the vehicle. Okay, and now coming to the actual thing, that there will be a lift, there will be a force above the vehicle body and the force under the vehicle body, and the summation of these two forces will decide that the whether this force is acting into the upward direction or whether the force is acting in the downward direction. So here you can see that the sum of which indicate the car body either naturally creates a lift or downforce. Okay, so now coming to the assignment section. So this is the three assignment. There is three questions which we have to solve. That is, what is the lift force, which I have already told you that what is the lift force. What is downforce, which already I have told you that what is downforce. And what is the effect of lift force onto the vehicle body. What is the effect of the lift force onto the vehicle body. So these three questions which you have to solve. That is, first one is what is the lift force, second one is the what is downforce, and third one is the what is the effect of this lift force onto the vehicle body. Okay, so this is the three questions which we have to solve, which I have already told you. Okay, so here I am going to end my lecture. Thank you. Thanks for listening my lecture. Thank you.